Hi guys, welcome back. This is day 3 out of 50 of our SAT Math Prep series, and today we'll be tackling the third problem type of SAT math problems, which is problem solving and data analysis. Looking at our first problem, it's of 3 difficulty, so a little more difficult. Um, Always take a glance at the graph or chart that you're given in these problems because can help you prepare for what they're going to ask. So we see texting behavior, talks on cell phone daily, does not talk on cell phone daily, and then total amount over here, total amount over here. Okay. In a study of cell phone use, 799 randomly selected US teens were asked how often they talked on a cell phone and about their texting behavior. The data are summarized in the table above. Based on the data from the study, an estimate of the percent of US teens who are heavy texters is 30%, and the associated margin of error is 3%. Which of the following is a correct statement based on the given margin of error? So whenever it gives you margin of error, it's saying, so for instance, 30%, margin of error of 3%, margin of error 3% means that the 30% can range from 33, which is plus 3, or 27%. So it's almost certain or very highly likely that the values will reside between 27 and 33%. So it's plus or minus always for margin of error. Looking at our answer choices. We're not really using the chart here much for this question, so kind of ignore that. Approximately 3% of teens in the study who are classified as heavy texters are not really heavy texters. So this answer is convincing, but we're going to leave it for now and come back later. Because I'll underline it like that. It is not possible that the percent of all US teens who are heavy texters is less than 27%. Okay. Given what I said earlier, it's highly likely, but not a guarantee. So this is saying right here, not possible. So that's going to be incorrect. And then C, the percent of all US teens who are heavy texters is 33%. This is also wrong because remember, it's highly likely that it's between 33% and 27%. And we don't know if it's 33, 27, 30, 31. So we can't make that assumption of it being 33%. And D, it is doubtful that the percent of all US teens who are heavy texters is 35%. So looking at 35%, that's outside our range over here. And given what I said earlier of it being almost certain that it's within this range, this is the right answer. Looking at A though, why it's wrong, approximately 3% of the teens in the study who are classified as heavy texters are not really heavy texters. We can't make that assumption because it can always be less. It can be 2%, 1% that are not classified as heavy texters. We can't just put a value of 3% and say that's the value. It can be from 0 to 3% that are not really heavy texters, not 3% exactly. A very wordy problem, difficult to handle. Okay, another 3 difficulty problems. I do not like these types of problems personally. Okay, looking at the chart, we have number of contestants by score and day. So we have 3 days and we have the amount of points they scored on each one and 20 contestants for each day. And down here, that's easier to digest. Total out of the 3 days. I'm just going to erase this quickly. That's not doing anything. Okay, let's read the problem. The same 20 contestants on each of 3 days answered 5 questions in order to win a prize. Each contestant received 1 point for each correct answer. The number of contestants receiving a given score on each day is shown in the table above. No contestant received the same score on 2 different days. If a contestant is selected at random, what is the probability that the selected contestant received a score of 5 on day 2 or day 3, given that the contestant received a score of 5 on one of the 3 days? So we're looking for probability that contestant receives score of 5 on day 2 or 3. And then we have given that the contestant receives a score of 5 on one of the 3 days. So we're looking for a score of 5 on one of the 3 days. So we're gonna, whenever it says given, we're looking at a fraction. Let's say x over y. X is what we're getting, and y is what we're given. So here we're gonna put the denominator as a score of 5 on any of the 3 days. So it's gonna be 7 over a given value, because looking at the chart right here, we have 7 as the total for the amount of perfect scores throughout the 3 days for all participants. And this is very important right here. No contestant received the same score on 2 different days. So that means that this contestant has an equal chance of getting these scores. We are going to now find the probability. So the probability that the selected contestant receives a score of 5 on day 2 or 3. So that's the part that goes in our numerator up here. On day 2 or 3 means we add these two. So day 2 or 3. 2 plus 3 is equal to 5 over 7. So this is the probability that the selected contestant receives a score of 5 on day 2 or 3, given this scenario down here. Okay. Moving on to our next problem. That's a fill-in problem again, so 5 over 7 would be your answer. Okay. Jennifer bought a box of crunchy grain cereal. The nutrition facts on the box state that the serving size of the cereal is 3/4 a cup and provides 210 calories, 50 of which are calories from fat. In addition, each serving of the cereal provides 180 milligrams of potassium, which is 5% of the daily allowance for adults. If P% of an adult's daily allowance of potassium is provided by X servings of crunchy grain cereal per day, which of the following expresses P in terms of X? So remember, expresses P. We're not given an equation here, so we don't have to manipulate it, but we have to create it from scratch. So it's very important that you keep this in mind, P%. So we're not writing decimals because we're going to write whole numbers, which is the percent. The number is the percent because that's denoted by the variable we're given. So we're making an expression for P, so P is equal to, and then which is 5% of the daily allowance for adults. So every serving of this grain cereal that someone eats is 5% of the permitted or allowed potassium serving for adults. So we have 5. We're not going to put 0.05 because that would be the decimal if we weren't given percent. So 5 times the amount of servings someone has. X servings. So P equals 5X would be B. Wait, what difficulty? That was a hard problem. Just because it trips students up tackling the percent and decimals. Okay, we're going to do our last problem here. The expression 0.35x represents the results of decreasing a positive quantity x by what percent? Okay, so there's multiple ways to tackle this problem, but we're going to do it this way. So 0.35x, the result of decreasing a positive quantity. So let's just pick a positive quantity. Let's pick 1 because it's a very easy number to handle. So we're going to put 0.35 times x, and our x value we're going to choose as 1 is equal to 0.35. So our x value decreased from 1 to 0.35. So we know it's decreasing, as it said in the problem, a positive quantity, which we chose, x by what percent is it decreasing now? Okay, so the percent formula, percent change formula is equal to old minus new over old times 100. And old here is just our initial value, and new is the new value we're getting. So we're going to get 1 minus 0.35 over 1 times 100 is equal to our percent change. So 1 minus 0.35 is 0.65 over 1 is just 0.65 times 100. And that's going to give us 65%. We can just throw in the percent here because we're multiplying by 100, which gives us a percent value. So those were the 5 problems we tackled today. I hope this practice helped, and if it did, please consider subscribing to the channel. I'll see you guys